Which one is not an inner orbital complex? The coordination complexes are categorized into inner orbital and the outer orbital depending on which d orbitals they are going to use. If it is uses n-1d, then it is called as inner orbital complex. If it uses nd orbital for the complex formation, then it is called as outer orbital complex. So if you have to form n-1d, if it has to use n-1d, then the ligand should be stronger. So that makes the electron pair up in the n-1d shell. If it has to use the nd orbital, then the ligand must be weak. That can't pair up the electron. So we'll see the options given. CONH3 plus. Here cobalt is in the 3 plus state. So the configuration of cobalt is 3d7 4s2, but since it is in the 3 plus state, the configuration will be 3d6 4s0. So there are 6 electrons in the d shell. And because of the presence of this strong ligand, that's NH3, these electrons are going to pair up like this. As a result, you have 3 orbitals with 2 electrons here after pairing up, and 2 d orbitals will be remaining. And this uses, since there are 6 ligands, each ligand is going to give 1 pair of electron for the bond formation. So the hybridization involved here, it is d2sp3, and inner d orbitals are used. So this is 3d and this is 4s. So inner d orbitals are used. This is called as inner orbital complex. The second option which we have here is CrNH3 plus complex. Here Cr is in the plus 3 state. Again the configuration will be 3d 5 4s1. So you, after removing 3 electrons, you have 3d3, and the electrons will be like and the ligand that makes the electron pair up like this. As a result, you have these 2 orbitals, along with that 1s and 3p orbitals. So this is going to form d2sp3 hybridization, which is again an inner orbital complex. The third option which we have here is FeCN6. Cyanide being a weak ligand, strong ligand, this is going to pair up the electrons. As a result, here iron is in the 3 plus oxidation state. So the configuration will be 3d5 4s 0. Again, it can use d2s p3 orbital. So again, d2 is the inner shell here. So this is inner orbital complex. And the last option which we have here is FeF4 2 minus. So here iron is in the plus 2 state. As a result, the configuration would be 3d6 so 6 electrons like this, and F being a weak ligand, this can't pair up the electrons, and there are 4 F coming up. So this is going to use the sp3 hybrid orbitals. So the hybridization which is observed here would be sp3 and this is not an inner orbital complex. So the answer would be this one, Fe F4.